Lesson 4-2, Example 2. Our objective is learning to write prime factorizations of composite numbers. Prime factorization, the prime factorization of a number is the number written as a product of its prime factors. So prime factors would be numbers that are prime numbers. For example, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7, 11, 13. These are all numbers where the only things I can do to multiply to get them are the number, multiply the number by 1. So these are all prime numbers. So for example, if I'm going to take the prime factorization of 12, well, I know that there are many factors of 12, including 1, 2, 3, 4, 6, and 12. Those are the factor pairs. But if I can also write 12, so I can write that as a multiple of 1 times 12, or not a multiple, but a multiplication of 1 times 12, or 2 times 6, or 3 times 4. But I could also write 12 like this. 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. This right here is what would be referred to as the prime factorization of 12. Because these numbers multiplied together come up with 12, but each of these numbers is a prime number. And we have no composite numbers in here. So that's what it means to have a prime factorization of a number. Multiplying those numbers together to get a composite number, but all the numbers that you multiply have to be prime numbers. So let's take a look at how we might find prime factorization of a number. Let's say we have the number 24. Well, I know that 24 is an even number. So 2 is going to be a factor. And what I have to multiply 2 by is 12. So let's see, is this a prime number? Yes. I'm going to circle that. Is this a prime number? No, because I know that it can also have factors of 2 and 6. Prime number, I'm going to circle that. 6, though, is a composite number. 2 and 3. And 2 is a prime number, and 3 is a prime number. And you might be wondering, why am I not using 1 in here? Well, if I used 1, I would just continue out. And 1 is not a prime number. Not prime. It is neither prime nor composite. So, our prime factorization of 24 I could write as this. 24 is equal to 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So here's my prime factorization. I could write it another way. I could use exponents. 2 times 2 times 2 could be written as 2 cubed times 3. Either way is fine. Both of these represent the prime factorization. Let's take a look at another possible way. This is one possible way to figure it out using a factor tree. This is called a factor tree. But another method is called the ladder diagram. And in the ladder diagram, let's say we have the number 45. I'm going to put this little L bracket underneath of it. And I know that that this is a composite number, and one of those numbers that I can pull out is a 3. So a 3 is a factor of 45, because 4 plus 5 is 9, and 9 is divisible by 3. And 3 has to be multiplied by something to get 45, in this case, 15. So 3 times 15 is 45. I'm going to put another L bracket there because 15 is also a composite number. 3 is also a factor of 15, and 3 times 5 would get us 15. Now at this point, I'm going to check, is this a composite number? No, it's a prime number. So this is where I'm going to stop. I can say that my prime factorization of 45 is 3 times 3 times 5. 3 times 3 is 9, and 9 times 5 is 45. So this is my prime factorization of 45, or I could write it 3 squared times 5 using exponents. Either way is fine. Now I could show this another way. Let's say I was doing 45, but instead of pulling out a 3 as the factor first, I start with 5. And if I do that, I'm left with 9. 9 times 5 is 45. Well, a factor of 9 would be 3, and it's 3 times 3 is 9. So 5 times 3 times 3, which works out to be the same. 3, 3, and 5. 3, 3, and 5. So it doesn't matter which factor you start with, but you want to get it all down to nothing but prime numbers.